Good afternoon everyone. Today we will have a lecture on steel structures. So already we have discussed the concepts regarding steel structure. So we have started the fillet joint. So again we will have some more numericals related with the fillet joint. Okay. So fillet joint is again an important concept which we have already started in previous lectures. So with the help of that fillet joint, or with the help of the concept of fillet joint, we will solve the numericals. Okay. So this design numerical I have written here. So this is nothing but the design numerical. The design of welded connections is there. Design of welded connections for angle sections. So here we have to design the welded connections for angle sections. So in which I am reading the problem. First, a tension member in roof truss having a single, that is ISA. So we are providing a single, that is ISA, that is Indian Standard Angle Sections. That means we are connecting a gazette plate with the help of a single angle section. So single angle section, that is Indian Standard Angle, having a dimensions of 100 by 100 by 8 mm. That means what this 100 indicates. So L1 side, the side of one side of angle, the other side of angle is again 100, and the thickness of that angle section is 8 mm. It is having a thickness of 8 mm. Again it is subjected to a factored load. So what this single angle section, it is carrying a load of factored load of 180 kilonewton. That means a factored load of 180 kilonewton will be bared by this single angle sections. Okay. So this single angle section will take a load of 180 kilonewtons. Find the length of 6 mm size of fillet weld. That means we have to find out, or we have to design the length of fillet joint. We have to find out the length of fillet joint which is having a size which has been given as 6 mm. So 6 mm is the size of fillet weld. So it has been mentioned here. The size of fillet weld is nothing but 6 mm. But we have to find out the length of that is angle section when it has been connected with the gazette plate, when it is being connected with an another member. Okay. So we have to find out the length of 6 mm size of fillet weld. Assume FU. FU is again the design stress, tensile stress. It has been given as ultimate tensile stress is given as FU is given as 410 Newton per mm square, and take FCXX. So what is the use of this CXX we will see in the problem. So take CXX which has been measured from the bottom, that is 27.6 mm. So it has been given as 27.6 mm which is to be measured from the bottom. Okay. So here FU is given. In some cases if the value of FU is not given, so then we have to use directly the value of 410 Newton per mm square. So there is no as such confusion. If it is not given, so then we can use this value of FU as 410. But in this problem it has been given as 410 Newton per mm square. Okay. So with the help of this given data, we have to calculate the length of a fillet joint when it is connected, when the single angle section it has been connected with a gazette plate. Okay. So it was a somewhat different numerical was there, and the somewhat different concept was to be cleared. Therefore I have used this method of teaching in which I will actually solve the problem in which various steps will be covered. So one by one we will solve the problems, and the various steps which it has been covered we will see one by one. So here I am writing down the solutions. First we will draw a simple figure for this in order to find out, or in order to clear this concept how this angle section it has been connected with the gazette plate. Okay. So this simple figure is there in which it has been connected with a gazette plate. So there is a member here, there is a member. I am drawing the member. Okay. So this member it has been connected with the help of welding to a gazette plate. Okay. So there is a member. So here this member is there, and it has been connected with and this is nothing but the angle sections. Okay. So this angle section, this is angle section, that is ISA. This is nothing but ISA, that is 100 by 8 mm. Okay. this angle section, it has been connected with the help of this gusset plate. This is nothing but the gusset plate. Okay. So this dimensions are 100 and 100. That means this horizontal dimension is also 100 and this vertical dimension is also 100. The dimensions of this angle, it has been given. So this is nothing but 100. Whereas this vertical side is also given as 100. Okay. This vertical side is total as given as 100. This is also 100. Okay. The size of angle is 100. That is L1. This side we are calling this as L1. Okay. So L1 is equals to 100. And this side we are calling as L2. So L2 is also 100. And what about the thickness? The thickness of this angle section is 8 mm. The thickness, it has been given as 8 mm. Okay. Again, it is carrying a factored load of 180 kilonewton. What is the size of weld? It is having a size SS 6 mm. What is the use of this CXX? So this CXX will be measured from bottom. Okay. So this will be measured from this point. So this CXX will be measured from this bottom end. So this will be measured from this end. So CXX part is from this end to the center of gravity. So we are assuming somewhat here as center of gravity, where the whole load is it is supposed to be taken care. So this point is, we are considering at this line the whole load will be considered to be accumulated. Okay. So this is this distance, it has been given as CXX. So CXX is the actual distance which has been given in the question. Okay. What is that distance? 27.6 it has been given. So CXX is 27.6. Okay. So I am drawing a straight, that is the CG that will be used for further process. So this will be drawn. We will draw the CG. Yes. Okay. What about the remaining distance here? So this distance, total angle from this point to this point, it is having 100. So 100 is L1, L2 is also 100. But CXX from bottom, it has been given as 27.6. So 100 minus 27.6, the remaining distance is 72.4. This 100 is the original distance of L1. CXX, it has been mentioned in the question, 27.6. So 100 minus 27.6. So this remaining distance from this point to this point, it has been calculated as, it has been given as, the remaining distance is nothing but 72. This remaining distance is nothing but 72.4. So it is nothing but the 72.4. How we have calculated? So just we have subtracted this. So just we have subtracted. That is how to find out the 72.4. So this total is L1 is 100. So 100 minus 27.6, which has been given in the question. So remaining distance is 72.4. That means the distance of top angle section, that is the distance of the from center of gravity to the top, is 72.4 and bottom is 27.6. So at this point, this factored load will be acting. Okay. So at this point, it will be acting. The factored load will be taken care at this point. Okay. At this point, the total factored load will be taken care. Again, we will draw somewhat welding part. So welding will be taken care. So at which portion we will provide the welding. So it is connected. This L1, it has been connected with gusset plate. That means we have to connect this gusset plate with the help of this angle section at this face, this L1 face. That means we will have the welding at this portion. Okay. So this portion will have, it will be welding. Okay. We will have this portion as welding and this portion as welding. Okay. So this combined, we have to find out the length. That is the welding we will provide at this top end, and welding we will provide as a fillet weld will be provided at this bottom weld. Okay. This figure will again we will draw this figure for simplifications. Again we will have some different simplifications. Figure is there. So here this is the point of gusset plate. Again this is the point for gusset plate. So this we are considering this as gusset plate, and this actual angle section, it occurs here. Okay, actual angle section it is at this point. The simplified figure for this is in this way. Okay, so this portion is nothing but the welding which will be done. We will do the welding here. Okay, this portion will be welding part, and this portion will be the welding part. Okay, and this is angle sections. 100 by 100 is this angle section is this part is this, and gazette plate it is this part is nothing but the gazette plate. Again, the load taken by this angle section will be here. Okay, so load taken by this angle section will be this, and this load it has been given as PD, that is given as load on these sections. Design load it has been given as PD as equals to 180 kilo Newton, which has been mentioned in the question, which has been given in the questions. Okay, so this 180 is the load which has been taken by this angle sections. It has we have drawn, this is the front plan is there, this is section line is there. The PD it has been acting as 180 kilonewtons. So this 180 will be balanced by the two forces. So first this 180 will be balanced by this again right side force will be there. In order to balance this 180 there will be a force here, but while seeing at the ends, so how this force will be balanced at the ends, so it will be balanced at the same directions. This 180 right side will be balanced by left side. So here there will be a left side force. Okay, so here there will be a left side force, but left side force again will be balanced by the two different forces. Okay, so that two different forces is nothing but F1 and F2. So we will draw a force F1 here, and we will draw a force F2 here. So F1 is the first force, and F2 is the second force. Okay, up to this point it has been cleared. So this factored load it has been taken as 180 kilonewtons, which is right side. So right side it has been at this end it has been right side. Okay, so but at this end it is left side. So this left side it has been balanced by two different right side forces. Okay, so F1 and F2 it has been balanced by this 180 that is acting at this. Okay, so there is no as such confusion regarding this, so therefore I have not drawn here. So just you have to imagine here 180 will be balanced by this 180 right side will be balanced by left side, and this left side will be balanced by these two different forces. Okay, it is balanced by the two different forces, or we can draw this force here also. Okay, this PD. So this PD it is balanced here. Okay, again this PD will be balanced by these two F1 and F2 forces. So here we have to find out the length of fillet weld. How to find out the length of fillet weld? So force is nothing but we have to find out the force, that is the stress. We have to find out what are the different formulas which has been used to find out these calculations. So I am again repeating the things. So first we have to find out the load taken by the that is the fillet weld. So P weld, what is the formula for load taken by the weld? So how to find out the load taken by the weld? So stress is equals to load per unit area. So stress is equals to load per unit area. Okay, so stress is equals to load per unit area. Okay, so load on weld is equals to stress is equals to load per unit area is the basic formula which we are always using, which we have already used in SOM also. So this, that is stress is equals to load per unit area. So load is equals to stress into area. The load taken by this it is nothing but the stress into area. This stress is design ultimate stress or design stress, that is FWD. Okay, we will see. So this load is equals to stress into area. The stress we are denoting here in case of FWD. So it is just the notations. Okay, into area, FWD into areas. So here we are denoting this as FWD into areas. Okay, So stress is equals to load upon area. So load is equals to stress into area, but this stress we are denoting with FWD. Just it is the denotations. Okay. So FWD again, this area, how to find out the area? So area is nothing but the how to find out area of weld. So area of weld is nothing but the length into thickness. Area is the multiplication of two things. So first thing is length, other thing is thickness. So length into thickness. So length into thickness is nothing but the area and stress in weld. Okay? Design stress of weld. Length will be as it is. What about the thickness? So thickness for fillet weld already we have covered in previous lectures. So how to find out thickness of fillet weld? So we are using the formula for thickness for fillet weld as 0.707 into S. 0.707 into S upon, again the formula is FWD. So in this way the load taken by the fillet weld is L into 0.707 S into FWD. If we are finding out the load per mm, this is load, total formula is load, but load per mm if we are finding out, that means we are dividing with length. Okay. So design stress, or we are finding out the load per unit strength of fillet weld or strength of fillet weld per mm. So strength of fillet weld. Strength of fillet weld, that is in m. So per mm, if we are denoting it as per mm, so then we will divide this with length. Okay. The formula will be changed as, that is equals to 0.707 into only S, because we have divided with length, and FWD. Okay. FWD. So this is nothing but the design, that is the strength of fillet weld, design strength of the fillet weld. So if we are denoting this design strength of fillet weld as PS, so PS formula, just for simplifications, we are denoting this as PS. So design strength of that is the strength of fillet weld per mm. The formula is PS, formula is into S into FWD. Okay. The original formula was the total, that is the design strength of fillet weld. Total design strength of fillet weld is nothing but this PS into L. PS into L. Okay. So if we are converting this, because this we have divided with length, if we are multiplying with length, the formula will be the original. So again we will write down the original formula. So P weld. The original formula is PS into L. Okay. PS into L. Just is the multiplication division concept is there, simple concept is there. So P weld, that is total, we can total quantity of weld. Okay. So it is PS into L. But what is PS? PS is nothing but this thing. Okay. 0.707 S into FWD. So there is no confusion regarding this, because the original formula is same, L 0.707 S into FD. Just we have divided L in order to have some different notations as PS. Okay. बाद में उससे क्या किया, again we have multiplied PS into L, the original formula. PS into L, this part is PS, this whole part is PS into L. So PS into L is the original formula which we have taken. So just for simplifications, we are, why we are separating this length? Because we have to find out this length. Okay. Why we have separated this thing? Because we have to find out the length of this fillet weld. So in order to calculate the length of this fillet weld, so we have separated this. Okay. So again, how to find out this length of fillet weld? So again the same thing. First we will find out FWD. By referring IS, that is 800/2007 page number 79. So by referring this FWD we have to calculate. So FWD value we will directly calculate this. Again F1 and F2 it has been given. So what is F1 and F2? F1 is nothing but the load. This in this case we are denoting with F1 and F2. F1 F2 is as good as this speed of weld, that is the load on weld. Okay, in this case we are denoting with P, but actually we are in this present case we are denoting with the F1 and F2. The F1 and F2 is nothing but the F, that is the load P. What is the formula for this? PS into L. If we are having force as F1, so we will find out with L1. If we are having the force as F2, so then we will have L2. So for separations, for calculations, for finding out the length separately L1 and L2, so we have derived this formula as PS into L. So we will have this PS into, we will write down here as PS into L here. The F1 value is actually, that is equals to PS into L1. Okay, and F2 value is actually, it is PS into L2. Okay, so in this way we have calculated F1 value as PS into L1 and F2 as PS into L2. F is actually the load taken by the fillet weld. This F and this load, okay, this 180 will be balanced by F1 and F2. This 180 will be balanced by F1 and F2. But what is F1? It is PS into L1. What is F2? PS into L2. Next we will find out the that is the stress, that is the formula in this we are using FWD. So first we will find out FWD. So how to find out FWD? So we will find out FWD first. So that is the design stress of fillet weld. Okay, design stress of fillet weld. For this we have to refer the page number 79 for IS 800 2007. So the formula for this is FU divided by square root of 3 divided by gamma MW. Okay, this formula is simple. You can refer the IS that is 800 2007 also, page number 79. So this formula we have taken from page number 79. Page number 79. So we have taken this from page number 79. So what is the value of FU? We have taken as FU, it has been given in the question as 410. So we will directly take this as 410 divided by square root of 3. What is gamma MW? Partial safety factor for welded connections, fillet weld. So partial safety factor for welded connections. So there is two types of welded connections: shop weld and fillet weld. Shop weld and that is the we can have in situ welding or shop welding. Okay, field welding or shop welding. So always we are using the shop welding. We are considering the welding as which has been created or which has been done in shop. Okay, so for this gamma MW we will